Hey guys, welcome to question MM425 of the Maths Methods Fortify study guide. So in this question we've got, at a particular school in Melbourne, it is known that 6 in every 7 students achieve a score of at least 50% on the end of year Maths Methods exam. In 2016 there were 49 students who took the exam, and we need to find the probability, correct of 4 decimal places, that at least 38 of these students achieved a mark higher than 50% on the Maths Methods exam. Alright, awesome. So first thing to recognize is the type of probability that we're going to be dealing with here. Now, the key indicators of our probability, which by the way is binomial, the key indicators are the fact that each student has the same probability to score higher than 50%. So each student has a 6 in 7 chance to achieve over that 50%. We've got a certain number of students that we're dealing with, which is 49. So we've got a certain number of trials or attempts. And every attempt is independent. So the fact that any student gets above 50% is independent of whether other students do as well. Okay, so that all tells us that this is going to be binomial. So what we're going to do is go into our binomial CDF, because we've got a range of values that we want to find the probability for. And it's going to ask us for lower, upper, N, and P. So our lower is our our lower bound of our range of values that we want, which is 38. Okay, so if we're looking for the probability that at least 38 students get above 50%, we're saying that 38 could, 39, 40, and so on and so forth until 49. Okay, so our lower is 30 and our upper is 49. Now our N value is actually also 49 because 49 students took the whole exam, right? Our P value is the chance that any given student gets above 50%, which is 6 in 7. That's our first mark. Our second mark comes from actually evaluating this. And so when we click enter in our CAS, what we'll get is the probability that x is greater than 38 is equal to 0.9601. That's our second mark. So guys, that's it for part AI. Let's move on to part AII. Part AII says find the probability correct of 4 decimal places that more than 41 of the students achieved a mark of 50% or higher on the Maths Methods exam, given that at least 38% of them achieved a mark of 50% or higher. Awesome. So what we're really saying is we're looking for the probability that our X value, which is the amount of students who got above 50%, we're looking for the probability that X is greater than 41 or more than 41, given that X is at least 38. Awesome. So the probability that X is 41 intersect at least 38 over the probability that X is at least 38. Awesome. Now the intersection between X is greater than 41 and X is greater than or equal to 38 is X is greater than 41. Okay? And so we've got this number line, got this 38 and 41. So everything greater than 41 is this point onwards. Everything greater than or equal to 38 is including this point and that point onwards. So the intersection is everything on this point forward, which is greater than 41. Awesome. So we're saying that this is the probability that X is greater than 41 over the probability that X is greater than or equal to 38. This is our first mark setting this equation up. So we already know what the probability of X is greater than or equal to 38 is. That's 0.9601. We found that in the previous part. So now we need to figure out what the probability that X is greater than 41 is. So we can again use our binomial CDF. And again, it'll ask us for lower, upper, N, and P. So our lower is not 41 this time, 42, okay? Because we're looking for everything bigger than 41 or greater than 41. Now 41 is not greater than 41, so 42 is our lowest bound. As always, our upper is 49, because that's the amount of students we have in the exam, and it doesn't have an upper limit on this value. Our N value is also 49, and our P value again is 6 on 7. Sweet. So clicking enter gives us a probability that X is greater than 41 equals 0.599. And then we can, that's actually a second mark, and then we can simply sub all this in. So we know that the probability that X is greater than 41, given that X is greater than or equal to 38, equals probability that X is greater than 41, so 0.599 over 0.9601, which equals 0.6239. That is our third and final mark for part AII, guys. That was AII, that's actually 3 marks. And that's it. So let's move on to part B. Now part B is going to completely change the question essentially. So we're just going to rub all this out. And part B in itself is a 3-mark question. And it says a particular student, Dylan, is sitting his maths methods exam and is working through the short answer section of exam 1. If he correctly answers a question, the probability that he correctly answers the next question is 4 in 7. If he incorrectly answers a question, the probability that he also answers the next one is incorrectly is P. Okay, so if he doesn't get it correct, the probability to get it incorrect again is P. Awesome. Dylan answers the first question correctly. If the probability that Dylan correctly answers exactly 2 of the next 3 questions is 153 on 343, find the value of P. Awesome. So let's deal with this in a tree diagram, okay? Because we've got this situation where we've got conditional probability, right? We've got this dependence happening here. Each question depends on whether he got the last one right. So when something depends on something, we want to draw a tree diagram. Now, we know that he correctly answers the first question. It tells us that in the question. So we can start our tree diagram by saying he correctly answered it. Now, the next one, he can either correctly answer it or incorrectly answer it. Next one, same, correctly or incorrectly, and then the next one, he can correctly or incorrectly answer it, and so on, okay? Awesome. Now we've got this, we've got these number of levels because the question asks us about the next 3 questions. Okay, so this is the next first question, next second question, and then the third question up here. Awesome. Now, where do we start with this? Well, we know that he answers his first question correctly, okay? Which means that the probability that he answers the next question correctly is 4 in 7, right? That's what our question's told us. So we want to fill out this this tree diagram. So we've got 4 in 7 to answer it correctly. Because these 2 have to equal to 1, he's got a 3 in 7 chance to not answer it correctly. Because he's answered this one correctly, the probability that he answers the next one correctly is 4 in 7. Probability that he answers this one incorrectly is 3 in 7. And again, he's answered this correctly, so the next correct is 4 in 7, and that's 3 in 7. Now here's where it gets a bit different. So because he's answered this one incorrectly, the probability that he answers the next one incorrectly is P. Okay, so that's P, which means that these 2 branches have to equal to 1. So the probability that he answers this one correctly is 1 take P. Okay, so these 2 add to 1. And then the same here, so he's answered this one incorrectly, so again this is 1 take P and P. And because he's answered this one correctly, the probability that he answers the next one is 4 in 7, this is 3 in 7, and then he's answered this one incorrectly, so this one is P, and this is 1 minus P. This is our first mark. Awesome. So I'm just going to rub this out now that we've written that down. And what we're looking for is if the probability that Dylan correctly answers exactly 2 of the next 3 questions is 153 on 343, find the value of P. Cool. So we're wanting the probability that he answers 2 of the next 3 questions correctly. So of the next 3, we've got this one correct, and this one not correct. So we've got this one, because that's exactly 2 of the next 3 correctly. Or we could go here, here, here. That's exactly 2, so correct, incorrect, correct. Or we could go here, here, here. So we want this one as well, okay? So the probability that he is correct twice and incorrect once equals all of these probabilities multiplied together and then added, okay? So this branch here, so 4 on 7 times 4 on 7 times 3 on 7 plus this branch, so 4 on 7 times 3 on 7 times 1 minus P plus 3 and 7 times 1 minus P times 4 and 7. Awesome. Now, we can simply just keep following this along. and we get 48 on 343 plus 12 outside of 1 take p over 49 plus 12 1 minus p on 49. And this is all equal to 153 on 343. Okay, because that's what the question's told us. That's how we're figuring this whole thing out. Summing all this together and moving it around, we get 105 on 343 equals 24 outside of 1 take p on 49. This is our second mark here. So getting to this point is second mark. And then from here, we can multiply both sides by 49. So we're going to move that to the top and then divide these by 24. And what we get is 1 minus p equals 105 times 49 over 343 times 24. Now, do we have our CAS for this question? Yes, awesome. So you can do this on your calculator if you want to. And then from here we can say that p is equal to 3 on 8. And that is our final answer and third mark for part B. Guys, if you have any issues with it, let me know. This bit is probably the most annoying part. But otherwise, let's move on to part C. Now, part C is a 2-mark question and says, for this same school, it was found that the time in minutes taken for students to complete Maths Methods Exam 1 is a continuous random variable x with this probability distribution, or probability density function. Part I, which again is a 2-mark question, says how long is any given student expected to take to finish this exam, correct to the nearest second. Now, whenever we hear that word expected, what we're looking for is our expected value, or our mean, okay? And in order to find the mean in a probability density function, we take our lower and upper bound, the integral of that, of x times f of x dx, okay? Now, it is a little different with this one because we've got 2 functions, but it's essentially the same thing. So what we do is we do exactly this. So from a to b, so 40 to 50 of our first function, so 449 on 2120 minus 11x on 2650 dx. And then we plus our mean of the other one. Actually, this needs to be times x, my bad. Times x times that. And then we have our other one, which is 50 to 60 of x times 9x take 50 squared plus 18 over 4240. That's dx. Now, that's our first mark, setting that up. According to our CAS, we get 10.904 plus 43.019, which gives us 53.923 minutes. But we're looking for the answer correct to the nearest second. So what we're going to do is times our 0.923, so that's our decimal section, times that by 60 because there's 60 seconds in a minute. And what we get is 55, which means therefore we have 53 minutes and 55 seconds. That's our second mark. So guys, that's it for part CI. Let's move on to part CII. Now part CII is again a 2-mark question and says, in the class of 49 students, how many would you expect to finish the exam in less than 49 minutes? Give your answer correct to the nearest whole number. Awesome. So firstly, we need to figure out the probability of any one student completing it in less than 49 minutes. Okay. So the way that we do that is by finding our probability that x is less than 49, where x is our time that it takes. And the way that we do that is by finding our area under the graph, right? Because our area is equal to our probability. So we go from our lower bound to 49, because this is the minutes that we're dealing with. And because it's in this function, we do it with this function. 449 on 2120 minus 11x on 2650 dx. And then what we get is, I would just put this in my CAS. So what we get is 2583 on 10600. That's the probability that any given student takes less than 49 minutes. Now, if there's 49 students in the class, then we can times this probability by 49, and that will tell us the expected number of students that will finish the exam in less than 49 minutes. Okay, so the number of students is equal to our probability, which is 2583. Actually, this is your first mark, by the way. 2583 on 10600 multiplied by our 49 students. Okay, and what this spits out is closest to the nearest whole number, 12 students. Don't forget your units, which is students, because we are dealing with a context in the question here. So guys, that's it for part CII, and that actually wraps up MM425. If you have any questions about any of this, as always, please hit me up in the comments below. But otherwise, thank you for watching, and I'll see you in the next video.